Imagine a dead star that is so powerful it makes the sun look like a firefly. Yes, I'm talking about the Vela Pulsar, a cosmic lighthouse that spins 11 times per second and shoots out beams of radiation that are 10 trillion times more energetic than visible light. That's right, this star is so bright you can't even see it. But first of all, what is a pulsar anyway? Well, a pulsar is basically a zombie star that refuses to die. It's what happens when a massive star explodes in a supernova and leaves behind a tiny core that is so dense it defies logic. Imagine squeezing the entire mass of the sun into a ball that is only 20 kilometers across. That's how dense a pulsar is. A teaspoon of its material would weigh more than 5 billion tons. That's like 900 times the mass of the Great Pyramid of Giza in one teaspoon. And that's not even the craziest thing about pulsars. These undead stars are also some of the fastest spinning objects in the universe. Some of them can rotate more than 700 times per second, faster than a blender or a helicopter blade. And as they spin, they emit powerful beams of radiation from their magnetic poles, like cosmic lighthouses. These beams can sweep across the Earth and be detected by radio telescopes as regular pulses of radio waves. That's why they are called pulsars, short for pulsating radio sources. But wait, there's more. A pulsar also has an insane magnetic field that is billions of times stronger than Earth's. And it rotates at incredible speeds, creating electric currents that produce different types of radiation along its poles, which we can observe as radio, X-ray, or gamma-ray flashes that repeat periodically. In this group, there are about 2,000 known pulsars in our galaxy, and some of them have planets orbiting around them. Imagine living on a planet where you can see a bright flash in the sky every few seconds. But be careful, because some pulsars are also magnetars, which are the strongest magnets in the universe. They can rip apart anything that comes too close with their powerful magnetic fields. So don't get too curious, or you might end up as space dust. Now, you might think that these pulsars are pretty cool and impressive, and you'd be right. But you'd also be wrong, because these pulsars are nothing compared to what some pulsars can do at even higher energies. And that brings us to our star of the show, the Vela Pulsar. The Vela Pulsar is located in the constellation Vela, which means sail of the ship in Latin. But don't let its name fool you, this pulsar is not sailing smoothly through space. It's actually wreaking havoc with its radiation. It's the brightest pulsar in radio waves and gamma rays, which are the most energetic forms of light. Gamma rays are so powerful they can penetrate through metal and concrete. They can also cause cancer and mutations in living cells. So yeah, not something you want to mess with. But even gamma rays have their limits, and the Vela Pulsar seems to have exceeded them by a long shot. Using a telescope called HESS, which stands for High Energy Stereoscopic System, scientists have detected gamma rays from the Vela Pulsar that have an energy of 20 tera-electron volts. That's a lot of energy. How much? Well, let me put it this way. If you could harness the power of one of these gamma rays, you could light up a city for a year, or fry 1 million chickens in a second, or power a DeLorean time machine. Yeah, that's how much energy we're talking about. And that's about 200 times more energetic than any gamma ray ever detected from this pulsar before, and about 10 trillion times more energetic than visible light. That's right, this star is so bright you can't even see it. It's like dating a supermodel, but she's wearing an invisibility cloak. What's the point? But how can a dead star produce such extreme light? Well, no one really knows for sure, but scientists have some theories. One theory is that the gamma rays are produced by electrons that are accelerated in the pulsar's magnetosphere, which is the region around the star where its magnetic field dominates. These electrons gain energy as they travel along the magnetic field lines towards the edge of the magnetosphere, where they emit gamma rays as they interact with other particles or fields. But there's a problem with this theory. The magnetosphere has a limit called the light cylinder, which is the distance from the pulsar where its magnetic field lines would have to move faster than light to keep up with its rotation. Beyond this limit, the magnetic field lines break and reconnect in a process called magnetic reconnection, which releases even more energy and particles. The thing is, the gamma rays detected by HESS have such high energies that they would require electrons to travel beyond the light cylinder to produce them. But how can these electrons maintain their alignment with the pulsar's rotation and emit gamma rays at specific phases? And how can they avoid losing energy as they escape from the magnetosphere? Another theory is that the gamma rays are produced by photons that are boosted by electrons in a process called inverse Compton scattering. In this process, low-energy photons such as infrared light collide with high-energy electrons and gain energy from them, becoming gamma rays. These photons could come from the pulsar itself or from its surroundings, such as its nebula, or its companion star, if it has one. But this theory is not flawless either. The photons would have to be very close to the pulsar to encounter the electrons that can boost them to such high energies. But how can these photons avoid being absorbed by the pulsar's intense radiation field? And how can they match the pulsar's rotation and emit gamma rays at specific phases? As you can see, none of these theories can fully explain the observations. And that's why scientists are baffled by the Vela Pulsar's record-breaking gamma rays. They don't fit with the current understanding of how pulsars work. They're like the black sheep of the pulsar family, refusing to follow the script. But hey, enough about Vela. Now let's shift our cosmic spotlight away from Vela and dive into some other pulsar-related wonders that will blow your mind. Have you ever heard of millisecond pulsars? These cosmic powerhouses spin so rapidly that they complete hundreds of rotations every second, making your kitchen blender look like it's stuck in slow motion. These stellar speedsters are believed to be ancient pulsars that were awakened by devouring matter from a neighboring star. Now here's an astronomical twist: pulsars with planets. In 1992, astronomers stumbled upon the first exoplanets ever detected, and they were orbiting a millisecond pulsar called PSR B1257+12. Yeah, math! These strange worlds probably survived the cataclysmic explosion of a star or asteroid belt, making them celestial survivors with a very unique address. But wait, that's not all. Some pulsars are like interstellar rock stars, shooting out fast radio bursts, or FRBs, that could wake up the entire galaxy. These FRBs are like cosmic firecrackers, lighting up the universe for just a brief moment, but with more energy than you'd get from a gazillion suns. Why do they do it? Well, that's a mystery that's still up for debate. Alien Morse code or just some black hole fireworks? Your guess is as good as ours. And speaking of style, certain pulsars have their own cosmic fashion show. They shoot out jets of particles and energy from their poles, creating shapes like donuts, butterflies, or even guitar strings. Because in the cosmic runway, every pulsar's got its own signature move. Well, what can I say? Pulsars are kind of like cosmic rebels. They play tricks on scientists and keep them guessing. They're like the universe's way of saying, hey, you don't know everything. So next time you look at the night sky, remember that there are billions of dead stars out there, spinning and flashing like crazy, sending us messages we don't yet understand. Maybe one day we will decode them and learn more about these cosmic wonders. Speaking of cosmic wonders, what if I told you there's a supernova that could change everything you think you know? Yeah, we're serious. We even made a video on this topic. Are you curious? Well, you should be, because it might surprise you more than a plot twist in your favorite movie. Unless your favorite movie is Tenet, of course. You can watch it by clicking here. But wait a second, before you go and watch that amazing video, I have something classic to say. Are you ready? Here it goes. If you liked this video, please hit the thumbs up button and share it with your buddies. And don't forget to subscribe and click the bell icon to get notified of our future videos. It may sound like a cliche YouTuber thing, but it really helps the channel grow. Thanks for watching. See you next time with more awesome space news.